All right, so in today's lesson, sure, we want to look at measuring the center of data, okay? This is an interesting concept because center can be defined in a number of different ways. In fact, what we're really talking about today is finding averages, okay? Now, we typically use average to talk about the mean. But average is actually a little bit more of a generic term here. The word average simply means a measure of central tendency, okay? How does our data tend towards a center? All right? So we have the mode, the median, and the mean. These all measure the center. The difference, however, is how you actually define center. All right, so let's go back in what we've learned in the past, and let's think about this, okay? If we're talking, first of all, about our mode, all right? We already mentioned earlier in the IP that the mode is the one that occurs the most often, all right? So think about this in terms of people. If we had a whole bunch of people and they were all crowded around one area, okay, they were kind of all gathered around one thing. We could call that thing they're gathered around kind of the center of their attention. Yeah, the center of attention. This is the mode is like the center of attention, if you want to call it that, okay? It's the most popular. Okay? It's the most popular one. Okay? You get cut it out. All right. So here we're defining center not based on a value or anything like that, but more based on what does most of the data gravitate towards. Okay? Or what piece of data occurs most often. All right? Then we have median. Someone explain what the median is. The middle, okay, what do you mean by the middle there?
It's like the middle value out of all of them.
Okay.
All the frequencies.
So like if you had 3 and 1, 2, and 3, 2 would be the median, and then if you had 1, 2, 3, and 4, you'd add 2 and 3 and then divide by 2 to get. Actually, no, it's the average. Never mind.
Well, no, you're right.
Is it? Okay.
Okay, you're right. Okay, but here we're talking about a middle or a center. How?
Like if you have a bunch of different frequencies, then you like whatever the middle number of all that is, that one frequency that contains them all is the median.
Okay.
If you were to like list each one out, I guess, and then cross out and cross out and then cross out, then the one left is like the one.
Okay. How do you have to list them out?
Like by their frequencies, right? Or no?
From the smallest to the biggest.
Okay, there we go. If you list them out from smallest to largest, you arrange them, okay? It's the one whose position is in the middle, right? Okay? So we could refer to the median kind of as a center position. All right? It's the one score where there's an equal number of scores above it and below it. Okay? Now, it doesn't matter what the actual value is, we just care about what the scores are. For example, we could have 1, 2, 3, 100, and 200. And what would the median be? It would be 3 because it's in the center position.
It's not the average. That's the mean.
Well, it's not the mean. It is an average. Remember, average is a generic term for all three of these. Okay? It's not the average as far as we usually are thinking of average as mean. All right? But
if
average.
they ask you for the average, you figure out the mean.
They're not going to ask you for the average. They're going to ask you for something for one of these three or possibly all three. Okay?
So like if they want to ask for all three, would they ask us average?
No, they would actually list them all.
Like average can be a lot of different things.
Yeah. So.
You're gonna ask like average and suppose that we know which one we mean.
I don't know, maybe. You should. Okay? Now, the mean is what we commonly think of when we hear the word average. Okay? You can blame the elementary school for that,
Blame the
probably.
education system.
But the mean, think about the mean. Here we're talking about a center, what?
It's the number which shows up the most.
No, that was our
Oh,
mode.
never mind, that's the,
The one like if you,
when you
the
add
one
them
right
all up.
in the center of all the frequencies, like if you add them up and divide them by how many you have them by with.
That's
Okay, that's how we find the mean. Do you know what that value actually gives us?
their average.
I don't know of any other word besides average.
Not the average, not the
Okay.
median.
This is actually a center that's based on the value. The other ones, really, we didn't care what the actual value was.
So center
In-
value?
In the mode, all we cared was which one happens the most. So we didn't care if it was the highest, lowest, somewhere in the middle. It didn't matter. The median, again, we saw 1, 2, 3, 100, 200. 3 is the median. It doesn't matter what the values are, it just has to be in the middle position. This is a center value. Okay? And the way this works, that's kind of light, but the way this works is this. Let's say that this is our mean right here, okay? You're going to have various scores on either side, all right? Here's different data points on either side, okay? Here I have 3 different points on either side. I actually don't have to have 3, exactly the same on both sides. I could have, a fourth one over here. The key, though, is the distances from the mean to each of the data points on one side will add up to the same thing as the sum of the distances from the mean to each of the points on the other side. Okay? So if I took these 4 distances on the right and I added them up, I'd get the same thing as I would get if I added these 3 distances on the left. Okay? It's a center value. Alright? So, average is just indicating a measure of central tendency. We have these 3 different possibilities. Okay? So let's talk about some of these in a little more detail here. We're going to run through this relatively quickly because these are terms that are familiar. We'll just kind of be adding a little bit to it each time. All right? The mode, if we're talking about a mode, we're talking about discrete data. Okay? So here is a bunch of discrete data. All right? Individual scores listed. And you'll notice that 27 occurs 3 times and all the rest occur at most twice. So 27 would be our mode, okay? If, however, we're dealing with stuff like we had on the one problem in our IP, like this down here, we have various classes, all right? And in that case, if we have continuous data, all right, remember we use classes with continuous data. We have what's known as the modal class. You dealt with that a little bit last night, okay? So in this case, you just look at the frequencies and make sure, though, that you actually, if you're asked for the modal class, it's not 11, okay? The modal class would be the heights from 185 up to 190. Okay, that's our modal class. All right? So, you've dealt with mode for years, but modal class is a little bit new. All right, so we wanted to make sure that we make that distinction here. Okay? In both cases, it is possible to be bimodal. All right? You could have 2 different modes. Alright, you can have more than that, but if all of them occur the same amount of times, then there is no mode. For example, if you had 2 of everything, there's no mode there. Alright, they all occur the same amount of time.
Wait, Mr. Jackson,
Mhm.
why is the so the 11 is a middle class? Isn't the 3 and 9 the middle class?
No. These are frequencies, so those are not classes at all.
No, but like I mean their heights. That's what, like.
Well,
Why is it it's 11? Like 11 occurs only one time.
well, no. Here's the thing. The heights are this column right here. These are frequencies. So there were 11 if you remember, these were, I think, basketball players. Okay? There were 11 people who were in that range of height. Okay? So this is the class that the most people fell into. Okay? So that's why this is what we're looking for. It's the modal class. Okay? Alright.
What if there's 2 modal classes?
You would just say, you would list both of them. Yeah.
So maybe like trimodal or like quadmodal.
You can, yeah. Yeah, eventually you'll get to the point where if they all have the same, then there's no mode, but yeah. It's just the more of those you have, the less useful that unit of measure is. Okay? Now, the median, again, this is just a quick review. There's 19 different scores here. Okay? So which one would be the median?
23.
Okay, 23, that's our 10th one, right?
I think so.
Okay, it should be. Because here we have, there are 9 scores down here, and there are 9 scores above. Okay? So that median is in the middle, and there's an equal number of scores on either side. Okay? If there are a total of 20 scores, like on this one down here, okay, then this is the 10th score, this is the 11th score, so the median actually needs to fall in between them, right? So our median is 23.5, but notice there are 10 scores below it, and there are 10 scores above it. Again, you have an equal number of scores on either side. Okay? By the way, we would still consider it this way, even if both of these, let's say this was also a 23. Of course, the median would only be 23 at this point, but you would still consider it to be between the two 23s. And you would look at this 23 as being below the median, and this 23 as being above the median. That's going to be significant later when we look at box plots. Okay, and you're finding lower quartiles and upper quartiles. Alright? So, even if they're the same thing, you still view it as being between the two scores. Okay? Let me get rid of that. Okay?
So you have to write 23 1/2.
Well, in this case, because it's between 23 and 24. If it were 23 and 23, the median would be 23. But when you're considering the lower half of the scores, you would consider that 23 to the left of it. And when you're looking at the upper half of the scores, you would consider the 23 to the right of it to be part of that upper half.
Can we use the restroom?
Alright, so next, the arithmetic mean. There's a couple of, there's a little bit of notation I want to make sure that you recognize here that you may not have distinguished between before. Okay? You'll notice here, we have two different means that we're talking about here. We have a mean of a sample, okay? The mean of the sample, and for that we use x with that bar over it. We just read it as X bar. Okay? And then we have a mean of a population. Okay? A mean of a population, we use the lowercase Greek letter mu. Okay? If you're writing that, you can write it like that. Okay? Now, you guys know how to find means. The means, if you're just looking at data, are found the same way, whether you're talking about a sample or a population. Alright, so that really doesn't, notice the formulas are exactly the same. Okay? Now, one last thing, and then I want to actually look at finding all of these when we have frequencies, because that can be just a little bit tricky sometimes. But let's talk about distribution, okay? Distribution. And this is where we can see things that where one unit of measure would be more useful or more meaningful than another one might be, okay? So for example, you can see here they have negative skew, bell-shaped curve, and then positive skew. And you'll notice this blue dotted line is our mean, okay? Now, if we have a bell curve, okay? We have a bell curve, and everything's perfectly symmetrical, or even approximately symmetrical, you're going to see the mean, median, and mode all pretty close together. Okay? The mean, median, and mode are going to be pretty close. Right? Where you get the skew, notice what we're talking about that's getting skewed. Okay? Here you have quite a bit of the data up here, right? But then you have some of these really low scores, and look at what it did. It pulled our mean to the left, or negatively, away from where the median and the mode were. Okay? By the way, on these curves, the mode is always going to be the peak. Alright? For the positive skew, you'll notice, again, the mode is at the peak, the median is the red line, but this blue line here, should probably use blue, the blue line here, our mean, has been skewed higher because of these high scores up here. Okay? So it's been pushed in the positive direction. That's why we call it positive skewed. Okay? Now, if you look at this this table down here, or this graph down here, the median, these are grades. Okay, so we had a whole bunch of A's. Let's reconnect that there. There we go. Okay, we had a whole bunch of A's, and then we had some B's, a C, a D, and then a few F's. Okay? This is not what you want to see as a teacher, but actually this was one particular class I had at one point. Okay, I had 13 students, and this is basically what every test looked like. We had a very big disparity in mathematical understanding in that class. So that was a challenge. But here, if I were to just look at my class average, okay, the class average, the mean, was a C for almost every test. Now, was that very representative of how the class did? Not really, okay? The median was a B, okay? So I knew that half the class was scoring an A or a B. Okay? That's pretty good. Okay? Now, I still needed to work on the folks that were down here, but with a median of a B, I could tell that, okay, this is an unusual situation, the median is a more useful value for me to consider, because I know, right, as long as that's a B, I've got over half the class, or at least half the class up there in the B range. Okay? Yeah.
So would this be a negative bell curve?
It's kind of like an inverted bell curve, yeah. I had a few of those. Part of the reason this happens, though, too, is because, think about it, your ranges are not the same. And A, B, C, D are all 10% ranges, and F is a 60% range. Okay? So statistically speaking, you're more likely to get an F than anything else. Okay? If we're just getting random grades, alright? But obviously that doesn't happen, thankfully. But that's why the mean can get skewed so far down. Okay? Because think about it, if I were looking at this in terms of their percentages, I knew that half the score had a B or higher. So here was my one end of the bell curve. Let's say one of those kids with an F got a 30, you know. That's way down here.
They didn't study.
So we got down there, and now our mean is over here as a C. That's again not representative. This whole distribution has been skewed down because of those really low scores. Okay? So that's the idea with our distributions and how those can be impacted. Okay? And also, this is why we use different scores at different points. Now, I want you to think about this just practically speaking. What are some situations in life where there can be a very big difference with some things that might skew a mean? If we were looking at those, besides grades in school.
What might skew, what might cause it?
Yeah, what's something in life where you might have certain values that are way higher or way lower than somebody else that might skew it? Huh?
Age?
Like in what context?
In Japan. Like they're not having like kids now, so like the working class is diminishing, so there's a lot more old people than young people. I don't know.
Oh, I wasn't aware of that. Okay.
What if like on a sports team, if like for half the season you're playing well, but then halfway through your star player gets injured, so then you lose a lot of games.
Okay.
So your scores, your average,
That's
your
a-
mean score.
Yeah, your mean score for the whole year was down lower because you're losing that one player. Okay.
Maybe like on a sports team, if it's like there's one really good player and all the rest of them are kind of mediocre, so like the salary, like that one player has like a lot, and everybody else's salaries are like 1 million versus like 60 million.
Okay, and that actually is a good example, not just for in sports, but if we're looking at demographics of a city, for example. Let's say that there's a city and there's like one neighborhood that has just a whole bunch of really, really rich people, okay? Or let's say it's a city and Bill Gates lives there, okay? Who's super rich. Well, you know, you're going to have the majority of people whose salaries, you know, are all in these ranges here, you know, somewhere between like $30,000 and $70,000, you know, is going to be, you know, where the majority of people in the U.S. are, okay? You've got some people who are making less, but then you've got this one guy way, way out here, okay? Well, that value is going to skew the mean up quite a bit, all right? And part of the reason is because there's only so little that you can make. I mean, zeros as far as you can go down as far as your salary is concerned, okay? But there's really no limit to how much you can make. Whenever you have a situation like that, you have the possibility there of skewing, and that's where the mean becomes less useful. A median salary might be more useful there. So your median, in that way, this person way up here still just counts as one person, and then your median ends up being a lot closer, you know, towards the middle of everyone else. Another case like this would be, for instance, like the cost of real estate or houses in an area. Okay, there's only so little that a house is going to be worth. I mean, at some point, the land is worth something, no matter how much of a dump it is. They can at least tear it down, and the land is worth something. Okay, so you have that. But you could take the same land and build this immaculate mansion with all these bells and whistles and everything, and it could be amazingly expensive. All right. So again, if you're looking at an area, the mean housing price probably isn't a good one to use. You're going to want to use a median. All right. So, were you going to ask something, or?
I was. I'm just confused as to why that's a negative skew and not a positive skew. Because wouldn't it be a positive since it's on?
Well, the majority of the data is up here.
Yeah.
But it's a negative skew because your mean is getting pulled down. Your mean is getting pushed negatively by these really low scores.
So it wouldn't be the
It's not the majority of the data is in the positive direction. It's what happens to the mean because of these few little ones.
Okay.
Okay?
Thanks.
All right. The last thing here, this is a formula you ought to be familiar with. Okay? Using frequencies. The key here is to recognize that these frequencies are telling us how many 3s we have, how many 4s we have, how many 5s we have. So that's why we would multiply these together, okay, and add them up. This is the sum of all the scores. And we multiply as opposed to doing 3 plus 4 plus 5 plus 5 plus 5 plus, and you guys get the idea. Okay? We don't want to have to write all that out, so we do the multiplication instead. Here's the sum of all the scores, but the important thing is that you divide by the proper value. You got to divide by the total scores, not the total different pieces of data, but the total of all the data, or all the pieces of data, okay, which is 40 in this case, okay?
So we divide by 40.
Yeah, so we would divide by 40. So yeah, our mean here would be that 278 over 40. And that comes out to 6.95. Okay? Alrighty. So try what you have in the IP for tonight. And we'll see you on Tuesday.
Have a good weekend.
Have a great long weekend.
Are you doing anything